polluted by humans. And and so yeah, we're talking about ecosystems. But the flux, the change, the variability, all the dynamics that make an ecosystem perhaps so confusing to us, that's nothing new. There's one ecological concept, though, among all of that we hear about a lot, and it's always in a bad tone. It's always posed as a threat, but very few folks seem to actually know what is an invasive species. Well, first, what's an ecosystem? The truth is pretty simple. An ecosystem is everything everywhere. It's just all the interactions of all the living and non-living things in a given area. And everywhere's got those. So small definition, but big implications. But for now, I just want you to bear in mind two questions as we get into this presentation. One, what is the leading cause of habitat loss and thus species extinction worldwide? And two, what is the most abundant tree species in Cook County? These will probably become clear to you as we get on with it here. A good analog for a balanced ecosystem is a sport game. Really, any sports games. You can tell that I'm super into sports. You got the context of the game. It could be a court, a rink, a field with all these different arrangements therein. You get all kinds of players with different specialties and skills and positions. But now imagine if you had a football game and it was entirely running backs and like water boys. Or if you had a soccer team where one team had 47 players, or a hockey game with 3 pucks. And worse yet, now imagine if the rink was completely full of one species of bush. Like what? So let me switch here real quick. Bada bing, and bada boom. So this. So take that thought and transfer it to every playing field. Imagine if the home of every organism out there was full to the brim with one species of bush, with no room in between. You might have noticed that a lot of our green spaces in this area look just like that. Like this one on the west side of Wolf Road, as opposed to this one on the east side of Wolf Road. Chock full of dead and dying trees with little to no flowers or bees, and you may or may not know that this is not normal. It's not functional, it's not productive, and it harms our quality of life in ways that you might not have anticipated. Like a fish in water, we're so accustomed to our degraded, debilitated, and infested ecosystems that we often don't know what's supposed to inhabit them or just how much they do for us when they're healthy. Chicagoland, you might be surprised to hear, is actually one of the most biodiverse and biodense regions in the temperate world. A region once lined with natural wonders and yielding some of the most incredible wetlands, the most fertile soil, the most superlative expanse of changing ecosystems. And all of these were created and influenced by a variety of people groups, of sophisticated cultures, ever since the glaciers left this place. It was created by the Anishinaabe, the Sauk and Fox, the Kickapoo, and the Ho-Chunk who lived here before us, and the Miamia in Iowa before them, and the Illinois and Mississippians before them. And they worked with the species native to this place until they themselves became a keystone species. I'll leave that up there for a sec so you can write that down if you're taking notes. But a keystone species is a species that upholds the biodiversity of the entire ecosystem. By the time Europeans came, they too had been working with the plants and ecosystems of their home, such that most of Europe was a cultural landscape as well. But we'll soon see why they were mistaken to expect that ecosystems in America would react the same to European species as do European ecosystems. They thought their way of life could translate across an ocean, but that belief is just one of the factors that would lead to another invasion, another form of colonization that was beyond the control of the colonists, but no less played an integral part in their genocide of this landscape and its cultures, invasive species. But to understand the problem, we have to understand what it was like before the problem. So you're looking right now, that's probably not good. That's a woodland chock full of dead trees and buckthorn, one invasive species that we'll hear about a lot today. But let's understand first the building blocks of an ecosystem, that being the geology, the hydrology, the climatology, the biology, and the energy, that being rocks and soil, water, you get weather, and then life and energy, which is just action. So every species, just as well as every grain of soil, fulfills a niche. They all do something unique that affects those building blocks, and through this effect, they each perform a function. Water takes grains of sediments and nutrients with it as it moves across and into the soil. The water reaches a stream through the soil where the nutrients feed plankton, who feed shrimp, who feed fish, who feed herons. Then it floods, okay? And all that water, as you can see here, deposits those sediments and nutrients in a floodplain or a wetland where pollution and pathogens, even overloads of nutrients and dead decaying plants, can be detained until the ecosystem can handle the flow, or turned by microbes and fungi into plants or something else entirely. This is called productivity, how much an ecosystem does. In the example I'm providing here, productivity is measured by how much floodwater is detained, how much carbon dioxide is sequestered out of the atmosphere in the form of dead plant matter, how much other stuff did that carbon help create, and how many nutrients, pollutants, and pathogens were captured, broken down, or dispersed. All ecosystems are performing functions and services that all living things need. They can potentially do it cheaper and better than any of the infrastructure we can build for those functions. In the case of water processing, that we're talking 6 to 8 times cheaper and more efficient. We call these ecosystem services, the necessary infrastructural processes that intact natural communities can provide. It is because of these ecosystem services that we've come to call green spaces green infrastructure, to stress the fact that every undeveloped plot of land is actually, by its own right, well-developed infrastructure. And the ecosystems natural to this region are exceptionally good infrastructure. We call these ecosystems oak hickory woodlands and tall grass prairies and oak savannas and floodplain forests, the lake strand, and all kinds of wetlands, which made up the mosaic of Chicago. So what kind of ecosystem services do these provide? Well, we're talking flood prevention and water detention, cleaning pollution, toxins and pathogens, of course, recycling nutrients, climate control, cooling your home, sequestering greenhouse gases out of the atmosphere, and so much more. That's more what my other presentations are about. So let's just get some hard stats out there just to paint you a picture. It's not necessarily for you to commit to memory here. But stuff like intact floodplains and wetlands, cleaning up 80 to 90% of particulate matter, and how restoring just 1.5% of a watershed to wetlands and floodplains reduces the peak floods by 29%. Here you have a great example. On the left, you see what your turf and pavement looks like in terms of runoff. And on the right, you see what natural ecosystems look like in terms of runoff. And this is actually one of my sites here. And I can tell you that there's still a lot of inundation and runoff in the worst rain events on the right side. So you can imagine what the left side looks like under those events. But also well-placed rain gardens and suburban parkways can actually reduce total watershed surface runoff by 90% in our lawns, streets, and sidewalks. That's crazy. Strategically having just 10% of a farmer garden converted to emulated prairie can do all of those things that you see on screen right now. We'll go back for a second in case you didn't get that. Yep. And in addition to that, that emulated prairie, along with our wetlands, are the most efficient and upscalable form of carbon sequestration at our disposal, better than trees at reducing greenhouse gases in the atmosphere. But if you do have trees, they do quite a bit for you too. not just cooling your home, but your entire neighborhood, and cycling moisture in times of drought, and recharging groundwater supplies, cleaning up about 60% of the particulate pollution that passes through their canopies. It's very, very special what all of these plants do for us, and completely thankless. No one's asking, no one's making them do it. Not only that, but for reasons that are still being studied, but are perfectly observable and measurable, there's a litany of physical and mental health benefits to having green space, and it doesn't need to be limited to us. Nonetheless, Cook County has only 17% of its original oak canopy left. Illinois has only 0.01% of its tallgrass prairie left, 0.02 to 0.06% of its oak savannas, depending on who you ask, and only 10% of its original wetlands. This is all despite the fact that 70% of natural ecosystems around the world are more profitable to us left undeveloped, including 100% of wooded environments. And that's not counting the benefits to biodiversity and wildlife. That's only counting water processing, air pollution, and carbon sequestration. So that was a lot for the brain to process, a lot. Just think how much it is for the ecosystems to process. How in the world does it do all of this? Well, these functions are a result of the one ingredient that is added to those building blocks we discussed to drive evolution and make an active ecosystem. It's called disturbance. So disturbance can be natural, like floods and storms, frost, blizzards, wind, drought, grazing, moving herds, winds, pests and diseases, and parasites and wildfire. These are all natural disturbances, all perfectly necessary. And disturbances can also be artificial, like farming and foraging, logging, hunting, building, digging, driving, war, fire as well, like we just saw in the last shot. I'd call this one an artificial disturbance. So disturbance is what drives evolution by creating problems for organisms to overcome, essentially. With root systems that extend anywhere from 3 to 20 feet underground, among other adaptations, our prairie plants, which I can also show you right here. Look at that. Look at those incredible root systems. Are you looking at that? Oh, so yeah. The only reason they have roots like this is because of all of those disturbances. And no more props, I promise. Yeah, basically around here, our ecosystems can survive the driest dry, the wettest wet, the coldest cold, and the hottest hot that the Midwest can offer. And the Midwest offers the greatest range of those things anywhere in the world. Ecosystems are always in gradual flux, communities changing within a range of change that remains fairly constant over a course of millennia. And we call that dynamic equilibrium. But they do eventually change into new ecosystems. We call this ecosystem succession. And this has been a lot to unpack. I don't expect you to remember all of these little factoids and stats and definitions. No. What I want to convey is just the sheer sophisticated complexity of our ecosystems. There's a lot going on, far, far more than we can account for alone, which should be fine because our ecosystems have got it covered. They know what to do, and this dynamic equilibrium begets ecological succession. They just get better and better at handling our infrastructure for us. Artificial or human disturbances, however, often cause such changes so rapidly and drastically that succession doesn't continue. It just restarts. And we as a culture are constantly, without thinking, alter the ecological building blocks in ways that someone at some point will pay for. When we remove the soil, we remove 100% of its ecosystem services, and we release 100% of the pollutants and toxins it retained. Same thing when we drain ponds and move streams. In the city and suburbs, it's almost certain that your own land's topsoil, the stuff that can make what you're seeing on screen right now happen, is probably removed. It was probably removed long ago for heavy brick buildings, which would have happened to this site too, as you can see by those sidewalks that already got put in there. But are artificial disturbances all bad? Not at all. You're looking at one right now. The fires that dominated and defined our native landscapes and their succession were usually artificial and on purpose, because the native nations knew that they increased biodiversity and productivity. But now this ecological context and the cultures that understood it have been so thoroughly removed or altered that our modern cultures need to be the disturbance that was once essential to this land. It's the changing context that allows species to become invasive in the first place. So here are the unsavory guests that would like to benefit from our ignorance. An invasive species is any species that, when displaced from the ecological context in which it evolved, dominates a new ecosystem at the expense of that biodiversity. There are always aggressive predatory and parasitic species out there natural to our environments, but those are just necessary components. I'm sorry, those rabbits in your garden or the possums in your attic, that is not an invasive species. If anything, you know, they're just trying to get along in their home with you there. But just like viruses are necessary to our world and our ecosystems, but just like viruses, when they spread to a new host, killing that host is likely, but it's never a good thing, even for the virus. So let's just establish that invasions are not good for invasive species. Every species seeks balance ultimately. Invasive species are just removed from the context in which they can achieve balance. And without intervention, it will take thousands of years and a lot of carnage for the restoration of that balance. So invasive species, they can be exotic, they usually are, or they can be native, taking over ecosystems from which certain disturbances or conditions once kept them out. With all invasive species, though, context is key. While many native species are only invasive in very specific conditions, many exotic species grow here like apples and aren't invasive at all. In fact, sometimes can benefit their local biodiversity. But you can forget about that part for now. Just, yes, you can get rid of that mulberry if you really want to. And otherwise, leave the convoluted mess of native invasives to the land managers. We'll worry about that. Today, we're just going to focus on the exotic ones, mostly plants. So part of why many people don't realize the dangers of invasives is because they still occupy a niche or a function that native plants once did better for us, but we still value. Phragmites, that you see on screen now, is a reed that inhabits most of what's left of Illinois' wetlands. And it helps soak up a little bit of water and sequester a little bit of carbon, but it also causes a lot more erosion and sedimentation and property damage and extinction. And as you can see there, there's no room for even animals or most insects to find their own niche. There's a lot more potential to biodiverse wetland ecosystems that can remediate a variety of pollutants and detain water at different levels and support important wildlife like pest predators and pollinators. Fun fact, about half of all species on Earth are dependent on some kind of wetland at some point in their life. But a wetland to them is not just the water, it's the plants. If it was just the water, what you're seeing on screen now would still technically be wetlands too. Really, why each of these plants are such effective invaders at all is because of four big factors. For one, these are pioneer plants that don't need good soil. They can colonize in the area even when the context has been removed. Two, these plants spread quickly, even in their home range, where there are species that have evolved to combat or benefit from these adaptations. Three, they're often plants of which descendants of Europeans are still quite fond, like English ivy and vinca. So they're tolerated or planted frequently. And four, while they benefit from disturbed soils and altered waterways and our negligence, many species become invasive due to climate change and disturbance loss, expanding into ecosystems they've never inhabited because they've become warm enough, wet enough, dry enough, or unburnt enough. With all of this to consider, it's no wonder that the most common tree in Cook County Most of what you're seeing on screen right now and all the underbrush there is buckthorn, Rhamnus cathartica. And buckthorn is a prime example of what happens when disturbances are changed or eliminated. Remember, most of our native ecosystems are dependent on fire in large part because potentially invasive native plants were kept at bay by only growing in fire-free areas. So real quick, let's switch to a diagram so I can illustrate to you what else we got here. So let's examine buckthorn as our prime example of an invasive. There's many ways to objectively evaluate if something is invasive, but for today's purposes, we're going with a rather simple, neutral, 6-stage model developed by Robert Collaudy and Hugh McIsaac. And I don't expect you to remember this model, to remember all of these little terms and stuff. I just want to give you a visual and explain to you so that you can understand, maybe just intuitively when something is definitely not invasive or when something definitely is invasive. So it all starts with a propagule, part of an organism that is used to make more of that organism. Let your dirty little minds run wild with that one. In this case, our propagule is a shiny dark berry, which must overcome stage 0 first. That is the uptake filter. Some European immigrants throughout the 18th century all thought that they needed hedges for their pastures and crops. So they had their friends back home ship out plenty of buckthorn berries. These were deliberate cargo, and so they were taken care of, and they've been cultivated a long time over there, so folks knew how to care for them. Easy. Buckthorn survives stage 0. Stage 1, transport vector. Well, buckthorn got shipped as practically a commodity to the New World on boats on purpose. Unlike many a seed that falls into the ocean or in ballast, no salt or sun could destroy these seeds. Survives stage 1. All right. Stage 2, environmental survival. The ship has arrived. The buckthorn seeds are picked up by a shepherd who plants them and cultivates them. They had it easy, using humans to do the survival work for them in these old, well-established ecosystems. This is the stage that, say, your hostas are at. Hostas aren't invasive, but they certainly survive in the environment and more. And then you get stage 3, establishment, or the community suitability filter, which sounds like something your HOA would make you do. This is where we watch to see how introduced species fare in competition with their new neighbors, right? So sometimes a new plant survives because it can interact with or suffer the native species at least. Sometimes it survives because it fills an empty niche, and usually it survives because it just makes a shit ton of propagules. It's just sweating babies. But these don't mean that it's invasive, just that it can become naturalized, like an apple tree. But here's a good point to cover real quick why buckthorn just blows stage 3 out of the water. Buckthorn's first competitive edge is that it leaves out earlier and sheds its leaves later than all of our native plants, starving them of sunlight. Then its berries and its leaves put toxins in the soil that prevent other seeds from germinating. Along with this, they make a lot of nitrogen. All plants need a little bit of nitrogen. They need it to build the green stuff, the chlorophyll that allows them to turn sunlight into energy. But too much nitrogen is the same as too much food. Some people can eat 6,000 calories in a day and gain like 2 grams, but most of us will probably go to the ER. Think that sounds bad? Well, how about their root systems that don't soak up a whole lot of water? Instead, they just compact the soil around their roots. And this allows the topsoil and the subsoil simultaneously to erode away, which adds more to sedimentation in our waterways, which contributes to more flooding. And since this annual floodplain species, the annual floodplain species can't get rooted when there's no topsoil, the water that does end up in the floodplain just sits there, and perpetual shade makes it into a mosquito's breeding ground. I really love pointing this out. Why do you think we have so many mosquitoes? It actually has a lot to do with invasive species. And how about just the fact that buckthorn's favorite associative species are also invasives, like earthworms, we'll get to that later. Starlings and house sparrows. They usually invasives only open up opportunities for other invasives. So without further ado, stage 4, spread. The buckthorn has been loaded, shipped, cultivated, and spread in its new home. And every new generation of buckthorn in this land must survive all of those stages again and again and again. At last, some communities of buckthorn are surviving and spreading in the wild alone as birds, especially the birds brought from Europe, feast upon their berries and spread them far and wide. Stage 5 is domination. That's where buckthorn's at right now. So buckthorn is so dominant that in a matter of less than a decade, a rich ecosystem with hundreds of species and tens of thousands of dollars of ecosystem services can be converted into a buckthorn forest filled with starlings and mosquitoes, a monoculture. And it's, a monoculture is an ecosystem that is just as characteristic, needlessly so, of American agriculture as well as most of the exotic invasives that we'll encounter around here. And to think that all of that could have been prevented by just a little fire. Little fires that just burn across the dead plants on the ground and then go out. Instead, we get this complete mesophication, the alteration, it's a new kind of ecological succession, if you will, in which sunny, fire-dependent communities are converted to closed, shaded, and fire-intolerant communities. But unfortunately, we can't just set those communities on fire. We would be rebuilding Chicago again. This is the genius of invasive plants and monocultures. They cause ecological succession to succeed only in their favor. In this case, it's mesification. So maybe all you've learned so far is that invasives are hard to define. Sometimes it's blaringly obvious that a species is harmful. Like, look here, all of that reeds, all of those reeds you're seeing, that's all Phragmites, and it goes as far as the eye can see, as far as that tree line in the background. That's just Phragmites in a huge, huge marsh over on the 294. So yeah, Phragmites, buckthorn, honeysuckle, teasel, it's pretty obvious with those guys, but sometimes it's more nuanced. Oh, here, this was referring to what I mentioned earlier about little fires. See that? Everything underneath the fire is totally unscathed. That's how cool these fires are, and I mean literally cool. But English ivy, lost my place there. Sometimes an invasive plant is only harmful in your garden, like daylilies here, or English ivy or daffodils, which are best kept captive in isolated raised soil beds with deep rails. But that doesn't mean that you can forget about propagules, those little things I'm tossing around in my hands. Those are a fine example of how a sterile flower can still spread because those tiny durable tubers can just get innocuously strewn about by gardeners and landscapers and construction and excavators and all that. A whole new English ivy plant can kill a stand of trees simply because someone tossed a clipping over their shoulder in the wrong direction. That's enough. That little clipping turns into a whole forest of English ivy. And context is huge too. Some species are only invasive in ruderal habitats, which this is not here. I.e. where the ruderal habitat being where the soil has been wasted or covered or removed. But they can't actually compete with established natives like we're seeing all over in our wetlands and prairies in some of these shots. Queen Anne's lace is a great example. A lot of you might be familiar with. It's a kind of wild carrot that might take over a pile of railroad ballast or an overgrazed field, but really stands alone in a prairie alongside plentiful natives. So yeah, people tell me all the time, I saw that Queen Anne's lace out there, you should go get rid of it. And usually I'm like, nah, I got better things to do, unfortunately. And in that context, Queen Anne's lace isn't invasive. It's just kind of there. It doesn't stand a chance, unlike honeysuckle, which you're seeing on screen right here. And then sometimes an invasive species is only invasive to species which hold the same niche, like the 6 species of exotic mantises in the US that are brutally replacing our native scientists. And as far as we can tell, that's about it. Unfortunate? Totally. Can we do much about it? Afraid not. What will it mean to our ecosystems? No one's quite sure. But it's likely squat compared to what the invasive shrubs can do. So we're going to focus on those. We don't have the time or resources to go after everything. With new invasive species introduced every year and conditions continuing to change, we must prioritize what we get rid of. And oftentimes, climate change and other changes mean that a species that is invasive now won't be later, and vice versa. Like this catalpa that you're seeing on screen, catalpa used to just be a popular ornamental that was native to central and southern Illinois, and now it seems to be becoming an invasive species in our floodplains and wet woodlands up here in northern Illinois. Not in all cases, but in a few. We're going to have to wait and observe. So before you accuse something of an invasion, check with local experts, consult local resources like the Chicago Botanic Gardens invasive species list or the field museums. And if you can't tell already by all the information I've just vomited, ecology is incredibly sophisticated. Don't stress yourself out with every little detail, all right? Chicago is one of the best cities in the world for naturalism and ecology. The information is out there when you need it. Now, most of the invasives I'll mention in this presentation are absolute no-goes. If you can get rid of it, then do, for the whole community. Because if you don't, you might get the most common tree in Cook County, buckthorn. If you hadn't guessed that already, that's the answer to that question. The most common tree in Cook County is buckthorn, accounting for about 36% of the entire canopy here. So if you do, however, find yourself trying to determine whether or not to get rid of a plant, there is one question that you can ask yourself. Does it seem to have a negative impact on my ecosystem's biodiversity? This is, in other words, the question that many native nations probably faced when deciding where to prescribe fires, where to cultivate useful species. Will eliminating this species benefit even more species? If the answer is yes, then I'd say, go ahead, have it removed. If the answer is uncertain, then just wait and observe or seek expert advice. But with changes being so constant and inevitable, how do we really prioritize? Well, we don't prioritize species per se, but functionality. The grand majority of the time, the native species that have historically evolved and spread within a site have the highest functionality, the highest productivity, and allow for the best possible biodiversity. So they'll take the cake. Most of us aren't working with original soil. We're working with the soil like you saw right there. Yeah, that's not even close to the worst of it. Once in a while, you just take what you can get. If you have growing from your dead gravelly clay soil, a white mulberry tree, which is an invasive species by definition, but it's capably harboring native insects, providing shade, feeding birds, and recycling nutrients, and you have no access to alternatives, it might not be wise to get rid of that white mulberry yet. On the other hand, if you have something that is prone to forming monocultures, which white mulberry isn't necessarily all the time, well, yeah, no, there's no point in keeping it. Get rid of it right away. And if you notice that your beloved white mulberry is spreading into some neighboring woodland or something, it might be time to take a hint. Alternatively, on a natural site, we get new species that we previously couldn't grow this far north, like that catalpa popping up all the time. We don't always kill them unless they enter the scene like Kool-Aid Man, wreaking immediate havoc. We observe and wait and watch and see how it cooperates and competes with the new community and how it does when it gets burned. And it still gets complicated because climate change might render something that's invasive now naturalized later. Similarly, we have those fruit orchards and countless integrated farming techniques that use exotic naturalized plants mixed with pre-existing natives, which promote incredible biodiversity in the few regions that still exhibit such agriculture, like much of the Michiana region right over here to my east. Next to no one is talking about getting rid of exotic crops. and the like. What we're talking about is using them to their greatest potential. Right here, you see even a garden of one of my family members, which is chock full of invasive English ivy and vinca, but they're also happy to let the trilliums, the wild ginger, and the oxalis and more to do its thing in there. It's better than nothing. It's better than nothing. And I will be the first to admit that English ivy and vinca are pretty hard to get rid of. So I don't blame you, Grandma, if you're here watching this. It's fine. We'll take care of it someday. Anyhow, the stress isn't all on you to save your little part of the world. I just hope you'll want to make it a little better by paying attention to its delicate ecology. However, when it does come to replacing our poisoned lawns and flooded turfs with dead zone gardens and native communities, and our dead zone gardens with native communities, there is a strategy to it. Every one of the 1900-ish vascular plants native to northeastern Illinois has a specific role where it performs a specific function. So regardless of the context that you're dealing with, even this empty gravel lot, there are native plants that can sort that out for you. Just give each plant what it wants by letting it do what you need. And it goes beyond plants when making choices that affect their ecosystem. If you're diverting water somewhere, make sure that water isn't causing problems to someone else. Consider diverting it into a bioswale or a rain garden. That way, the excess water only has beneficiaries. Adding pavement somewhere, consider more durable, permeable pavements, at least in part. If you have a mosquito problem, ditch the bug bags and zappers. Those kill more pollinators than pests. Mosquitoes aren't attracted to light or clear plastic bags. These instead encourage more habitat for bats and dragonflies who eat mosquitoes, burn citronella and other aromatics, and yada, yada, yada. If you have vegetable beds you're trying to protect, well, you can plant plants that the wildlife would rather eat than your vegetables. And there are natives that are adapted to that and look handsome as hell, even when they've been chewed up. Or you can plant plants that will bring in the predators for your pests. Plant alliums and mints and stuff like that, which are repulsive to deer. They don't even want to come near them, but which will attract the predators of all your aphids at the same exact time. It's brilliant. Basically, your home ecosystem has the luxury of being your ecosystem. Unlike all of these woodlands completely taken over by monocultures of buckthorn. By the way, this is one of my sites as well. We're working on it. But I just wanted to show that because I'm proud of it. Anyway, there you go. A few examples of green infrastructure that are going to be passing me by on screen. So basically, yeah, it has the luxury of being your ecosystem. You can do whatever you want with it. It can be whatever you need it to be. Whether you want a lower energy bill or a higher sense of falutin that you can laud over everyone else, knowing that you got the sweetest smelling farts in the neighborhood. And most importantly, do you want a low maintenance, high yield garden that only needs as much care as you can give? Well, there is some configuration of native plants that can get that done, get what you want done. And there is someone in your area who can probably help with it. And the best part, native gardens are cheap. They can even be free. Just don't poach. Our nature preserves are under enough stress. Thank you. Just got to put that out there. Now, the removal of all these invasives is not the only thing that restoration entails, getting rid of lawns and replacing them with natives and such. If I hadn't made it clear, restoration is also about the contexts and the associations, the checks and balances between organisms, the water regimes and all of that stuff, which is what things like this, like these bioswales, which you'll notice we burn, are meant to handle. This is providing habitat while also cleaning and is cleaning our water and preventing our flooding. But with plants being the primary organisms in most ecosystems, they tend to do a good job of setting the scene for all the necessary fungi, arthropods, microbes, and other critters that make up the ecosystem's biology, as well as all the functions that you need. So generally, you really just need to consider the plants. Sometimes we do get a little more involved, altering water regimes and streams and trying to alleviate erosion and sedimentation or restoring proper drainage. These are all within our grasp as well, especially in our urban ecosystems. Because we got to consider the artificial context and what's most feasible or helpful alongside it. Planting trees along pavement, for example, it's extremely stressful to trees, but extremely beneficial to us. Planning green infrastructure for water management is an incredibly complex planning process. We have to design and experiment with engineered ecosystems that wouldn't occur in nature. And that's okay. We're creating circumstances still that benefit other organisms and the structured environments that they need to survive. But working it into our urban ecosystems, this can be done just as well in the loop as it can in a Brookfield backyard. But since not all of us can light 50-acre fires or throw down dozens of trees with a huff and a puff, we do have to resort to what I want to talk about last here before we get into the invasive lineup is herbicides. And in the meantime, there's just going to be more green infrastructure going by behind me. But herbicides are something that we restorationists often think of as ecological chemotherapy. It's not the best option. It can have negative effects, but the alleviation of invasive species does so much more for the environment than well-trained herbicide use can refute. It's a risk we have to take. And there are those out there, including myself, who are experimenting with biological and mechanical methods of treatment as opposed to chemical ones for invasive species. But we don't have the time to rely on that. Here you see a mechanical method of reducing erosion and trying to reduce water velocity and restore some normal drainage to a habitat. And there's a lot that we can use all of that dead stuff for. That's all dead honeysuckle that I cut, invasive species, which is put to another purpose and rather than being wasted, you know. And over time, the ecosystem that's going to be created from this, that's going to succeed because of this, will alleviate any effects that the herbicide we put into that ecosystem could cause. Seriously, we're very well trained. We use direct application methods, meaning we only put herbicide right onto the plants unless the area that we're spraying is exclusively containing our target species. And we also primarily use herbicides that are either specific to the family or species that we're targeting or are pretty much non-toxic to all terrestrial animals like triclopyr. Also, triclopyr breaks down in a matter of hours, sometimes under the right conditions, and days under the wrong conditions. So, you know, again, it's the lesser of the evils. In most cases of herbicide use, though, it is heinous. It is irresponsible and indiscriminate. Agriculture, horticulture, and even the transportation and manufacturing industry use herbicide like it's salt and pepper. We're talking chemicals that regularly send kids and dogs into hospitals, that sterilize our reproductive systems, that kill our gut biomes, that cause leukemia and lymphoma and cancers abound. Yeah, we're not doing that in restoration, I can assure you. But let's look at one more thing here. Without further ado, let's get into the lineup of our culprits, shall we? So I'm going to pull up another thing here. Okay. And let me just show it to you guys. Boom and boom. Okay. So without further ado, let's take a look at some of the worst offenders in Cook County, mostly focusing on plants. And I'll describe to you a little bit on how to identify them, why they're invasive, where they grow, and maybe give some ideas on replacements. But let's just jump right in. So this is buckthorn. This is our Rhamnus cathartica. And for one, you can see, well, most plants, look at my fingers here, okay? Most plants, their leaves and flowers and such are either opposite on the stem, directly across from each other, or they're going to be alternate, okay? Opposite or alternate. There's also subopposite, which is basically alternate, but only barely. And that's what buckthorn has. You see, here's opposite, here's subopposite. Okay. So that's a good way to start. And also you got spotted, smooth bark with those black, shiny buds and black, shiny berries. And there you can see the spotted, smooth bark on the stems right behind those berries. Okay. It's got round leaves that are slightly toothed. And also that right there is your most defining feature for it, is how the stems, the twigs, modify themselves into little thorns. Now, I think we've talked enough about buckthorn, so let's move on to those honeysuckles. Honeysuckles are also a big mesificator and do pretty much everything I said buckthorn does. These guys are culprits of all the same offenses. I don't believe they're allelopathic, though. They don't technically poison the soil. But we got a few different species of honeysuckle to watch out for. They all share relatively the same characteristics. So they've got these leaves that are pretty round but tapered at the end. They point at the end. And at the axis of the leaves, the axis right here, you usually get a cluster of red berries. Before the berries, obviously, you're going to get clusters of little white flowers. And we got a few species of honeysuckle, like I said. Right now we're looking at Lonicera macchii. But we also got Lonicera tartarica, which has pink flowers and a little bit rounder of leaves. We've got Lonicera moroi, which have less pointed leaves and tends to spread a little bit more rather than getting super tall like our macchii. And then we have Lonicera japonica, which is a spreading, creeping vine with barely pointed leaves on it. But in all cases of Lonicera, you're not just looking for those berries and those flowers, you're looking for these opposite leaves. And if you're still confused, at the base of each of those leaves, oh, well, look at me, so prepared here. I didn't provide an example, but at the base of each of those leaves, you've got a little itty bitty tiny gland. And it's quite noticeable, but it's tiny compared to the leaf. Those are called stipules. Every honeysuckle is going to have two of them at the base of those leaves. Okay, and that's what it can do to your ecosystem. Next, we got multiflora rose, which I showed you a bit of earlier. Now I'm going to show you a neat trick. There's a lot of native roses in our region and a lot of exotic roses. This is the only exotic rose I'm familiar with that's invasive. But all of our old world exotic roses have stipules too. So do our new world ones at the base of their leaves. Okay. So look where my cursor is at the base of the leaf. And this whole thing is a leaf, by the way. This whole thing is a leaf. And you'll see they got stipules that are long and feathery and deeply divided. You see that? They're like spiny. Okay. None of our new world roses have that. Only old world roses have that. All right, so all of our new world roses, yeah, they're going to have flat stipules. They might still be long and tapering, but they're not feathery and spiny. All right. Here's basically what it looks like, the flowers and the leaves. It's got really small and numerous flowers, but it's those stipules that it's going to really give you the definition. Now there's burning bush. We all pretty much know what burning bush is. And did you know that it's invasive, especially a little further east in our sandier, more beech maple dominated forests in Indiana and Michiana and such? It becomes a serious problem over there. And the easiest way to tell it from anything else is it's opposite as well. It also has little tiny stipules, as you can see right here at the base of this leaf. But unlike any Lonicera, it has these wings of cork on the stems. That is what cork is, by the way. Fun fact. All right, so burning bush. Now, burning bush grows in woodlands and forests, and it is also a mesificator. All of these ones I've gone over so far, that is their greatest impact. They are mesificators. All right, now we've got everyone's favorite. Ooh, calorie pear. Yep. Sweetest smell in the world. Look at those gorgeous flowers that are just revolting. And these fruits as well. These fruits on Pyrus Killeriana are a pretty dead giveaway. But if you're still confused, a lot of Pyrus Killerianas are also going to have, let's see here. They're also going to have pretty round leaves. And you'll notice at the end of the twigs here where the berries are forming, it's really, really thick. When those berries and leaves are gone, you get these big, fat, fuzzy buds that are even thicker than the thickness of the twig. That's a pretty good way to tell that it's Pyrus Killeriana in winter. These things take over open fields and prairies rather than forests and woodlands, but pretty much are doing the same thing, more or less mesificating. Now we've got black locust. This is Robinia pseudoacacia. Black locust comes from a little further south. It might wind up becoming naturalized here someday. We're not really sure. The easy way to tell it right off the bat is it's got these deep, deep furrows in the bark. It's got deep, almost trellis-like bark, okay? And then, of course, it's got your classic fabaceous leaves. Everything in the pea family has leaves that are kind of like this. And it also, everything in the pea family has flowers kind of like this and fruits kind of like this. Go figure. But we only have 2 trees around here, like 2 big forest trees in the pea family. And this one is the invasive one. You can tell it apart because it's got these smooth, reddish brown thorns. That's all you really need. If it's got pea leaves, pea flowers, pea fruits, and smooth, reddish brown thorns, probably working with black locust. All right, there you go. That's the flowers IRL. And there's the tree as a whole. Now, we got Chinese privet. This one, again, becomes a little more a problem as you get further to our east. And also, it is opposite leaved. It also has little stipules on there. Frankly, if it has opposite leaves and stipules and it's killing everything else and nothing else is growing with it, there's a good chance it's an invasive species. Just make sure you ask. But Chinese privet grows very, very straight. It grows from suckers. The branches don't divide very much. They don't have a lot of twigs coming off them. It's basically just one branch, one branch, one branch, individual stems coming out of the ground and leaves and berries growing directly off of those stems. Don't really have a lot of branches or twigginess or anything like that to them. Makes a beautiful hedge. And that's pretty much it. Then we've got another kind of buckthorn, pretty similar to our common buckthorn, except it doesn't actually have thorns. But in almost every other regard, it's almost the same. It's got spotted smooth bark. It's got shiny black berries. It's got pretty simple round leaves. In this case, without serration or dentation, the leaves are smooth or just undulating on the edges right there. And this one is also a mesificator, but it tends to be exclusive to wetlands. Our common buckthorn loves wetlands too, but this one specializes in wetlands, hence the specific name alnus, which is a reference to the fact that it looks a lot like alders and stuff like that, which are famous wetland bush. Now we've got Celastris orbiculatus, which is still planted in corporate gardens everywhere. This stuff is a creeping or climbing vine. It can grow as a ground cover. It can grow up into the trees and kill the crap out of them. And it's got these tiny, teeny, tiny little flowers without petals and these pretty simple round leaves. Very, very few plants around here have such round leaves. We do have native Celastrises, Celastrae. So never mind. We do have them, but the grand majority of the time you're looking at the invasive one. It's pretty hard to find the native ones these days. And you've probably seen these fruits in fall and winter time, especially in decorative wreaths and, you know, in like display cases and stuff. That's Celastris orbiculatus, oriental bittersweet. And this stuff absolutely destroys forests, not by mesification, but because it's a climber. It suffocates trees, and that's not good for the Celastris. It doesn't do that in its native range. It's just that this species here is not compatible with the same insect predators and parasites that our native ones have. So, go figure. And there you go. That's what it does to stands of trees. Brilliant. All right, now we got autumn olive, also a little more common in our eastern sectors. It's got these kind of glaucous, like they're not rough, but they're not smooth leaves. They're covered in little tiny glands, and they've got these four-petaled flowers. I believe those aren't technically petals, but we won't get into that. And there you go. It looks like an olive tree from afar. There's very few things to mistake it for, which is lucky for us when you're looking clear across a forest of beech and maple with nothing but spice bush and you see an autumn olive. You know it's an autumn olive from quite a distance, but those leaves are a pretty dead giveaway. All right, now let's move on to some forbs. We got Alliaria petiolata. It's garlic mustard. We're mostly familiar with that. And like everything in the mustard family, it has four-petaled little flowers. And these leaves here, these heart-shaped leaves with the squiggly edges. Easiest way, though, to tell if it's garlic mustard is break a leaf off and smell it. This stuff takes over our spring woodlands. It doesn't allow a lot of our spring ephemerals and other little vegetations and fungi that pop up in that wet time of year to feed our pollinators. And unfortunately, garlic mustard doesn't provide a lot of food for our pollinators. It decays extremely rapidly. It's just kind of like water weight on our woodlands. And it severely reduces biodiversity when it's allowed to go off. Luckily, it's pretty easy to eradicate. Pulls out of the ground real nicely, and it's a biennial. So when it flowers and bolts like this, it's going to die anyway. As long as it's flowering, if you don't get the whole root system when you pull it out, it's fine. It's probably not going to recover from that. Sometimes it will, though. But like I said, those root systems are really, really easy to pull. Moving on. Oh, boy. Oh, God. If you have a garden in Cook County, probably dealt with Campanula, Rapunculinoides. Oh, I can never get that one out. Creeping bellflower. You can see from this little diagram, look at the stolons there. Look at those roots, those root and rhizome systems. That is the reason for this thing's success. It will just develop rhizomes and roots underground that fill every cubic inch with themselves and stretch down, 2-3 feet into the soil. You can turn the soil, you can till it, you can do whatever you want, and you're not going to kill this stuff without herbicide, frankly. I'm just going to break that to any of you who are dealing with it right now. Unless you got years of patience and no back problems, just use herbicide for the love of God. But that's what those flowers look like. I won't go too much into that one. You've seen them before. It's got these bell-shaped flowers with the curling bracts curling up and around these stems. All right, then we've got winter cresses, yellow rocket cresses, all of these mustard family things that are all pretty similar. These are very close relatives of kale and broccoli. They're delicious and nutritious, and they grow everywhere. And they were brought here in the first place because they used to be a pretty staple vegetable in Europeans' diets, and we've just forgotten about them. So those are everywhere, free food, just everywhere, taking over our ecosystems. It's got these leaves that you'll notice when they're young, when they're rosettes, that's when they're best for eating. They've got these deep divisions in them. This is technically one leaf, but you'll notice it's got these super deep sinuses, and then it's got a little lobe, and then an even littler lobe, and then an even littler lobe. So that's your mustards. But they've also got, of course, these clusters of four-petaled, in this case, yellow flowers. You see a bunch of yellow flowers poking up on big stems over a field somewhere. It's pretty much guaranteed to be one of our invasive mustards. Then loose strifes. Oh boy, we've got a host of loose strifes, and there actually are a couple native ones too. I still have yet to find them, but we've got plenty of exotic ones, and they all follow roughly the same characteristics. So we'll look at the flowers here. You've got, you've got 6 petals per flower. They're usually pink or purple. You've got opposite leaves on these ones. The leaves clasp the stem. So there's another quick botanical lesson. Most leaves are either sessile or petiolate. Petiolate means they've got a little stem a little stem. Here's the leaf. Here's the stem attaching it to the rest of the plant, right? Sessile leaves just clasp right to the stem, okay? And loosestrife, it's got 6-petaled pink flowers, these nice, just erect stems with sessile leaves clasping right to them. And Lithrum completely devastates our wetlands and ecosystems. Here you get a better look at those sessile leaves, by the way. Completely devastates them. I've seen it just wipe them out. It's right up there with Phragmites. In fact, it's one of the few things that can compete with Phragmites, unfortunately. Then let's go on to the teasels. You've seen these on the roadsides before, especially that one on the right. That's when they look like when they're dry. This is another biennial species. So if you get it when it's flowering, you can just clip off all the flower heads and clip it down to the ground, and you don't got to do anything else. No herbicide needed for this one. However, it's extremely aggressive because it bolts way earlier than our native species. That's the case with a lot of these invasive forbs. Our native species don't need to bolt until late June, early July. That's not the case where these species adapted. They're in a hurry to bolt really early in the season, and they shade out our natives pretty easily because of that. It doesn't help that teasel, a single one of these plants can put out 10, 30, 70,000 seeds in 1 year. And those seeds can last up to a decade in the right conditions. Usually they only last a couple of years and stuff, but yeah, serious contender in our ruderal and sunny open habitats. Okay. So there you get a good close look at that. Important thing, and very important thing. For one, okay, you get these sessile leaves that create a cup around the stem, usually filled with water. Very important, though, if you have to treat this stuff on your own, on your property, is that every flower grows in threes. If you see one head of teasel, you do not leave without finding 2 more. I am so insistent on that. And if you don't clip all of the heads and then clip it all the way down to the ground, it's gonna bolt again. And wait till it flowers, because if you clip it before it flowers, the plant doesn't know that it's done yet, and it's gonna keep bolting, okay? Moving on, we've got our thistles, sorry. So there's a few different thistles that are invasive, and I'm gonna cover them all with one go here, okay? So basically what you're gonna look for on a thistle to determine whether it's invasive or native is when you lift up the leaf, is it the same color on bottom as it is on top? If it's not, you're looking at one of our native thistles. If it is, you're looking at one of the invasive old world thistles. Super handy, real quick diagnosis right there. You don't even got to know the species. You lift up the leaf. Is it the same color on both sides? Okay, it's an invasive thistle. You can also tell thistles, of course, by flowers that look like this, kind of like artichokes, which is because they are very closely related to artichokes. But they've got these crazy, what we call ovaries on there, that all of these pink or purple little itty bitty tiny flowers pop out of in the hundreds, okay? Then there's mullein. This is a problem in our drier areas out west. Here in the Midwest, it's actually not that big of a problem, but if you find it on your property, I'd still recommend pulling it because it's an easy one to pull. This is another biennial. It's got those velvety, soft, lovely leaves and these spikes of yellow flowers. There's the rosette of it. You've probably all seen that before. And there's the flowers on it. Pollinators do like the flowers. It's not the most nutritious food for them. And again, this stuff isn't really that invasive in Chicagoland, but we still generally pull it. Then you got crown vetch, another pea family plant. Basically, if you see these characteristic pea flowers, meaning they've got the banner on top, you see that banner, and then the other petals kind of closing into a slipper on the bottom, okay? That is a pea flower again. And crown vetch forms them in these balls, okay? There's just a perfect orb of pea flowers. We don't have a lot of natives that do that. They've also, if you look at the leaves aren't as round as a lot of pea plants. They're pretty elongated. We call that lanceolate sometimes. And as you can see here, this stuff grows in sunny and rural areas as well and completely takes it over. This is one of the few that you really can't do anything except spray. And there's nothing you can do to get rid of it except spray herbicide on it. Then you've got your burdocks. We're all familiar with burdock. Oh yeah, you remember these things? Okay, you know these big, huge pop up everywhere. It can be a pretty serious problem. Maybe not the highest priority, but I do very much recommend getting rid of it. And the tubers are very edible, basically like potatoes, just long, a little bit more fibrous potatoes. Okay. But yeah, we've all seen these big, huge, velvety, fuzzy leaves and these burrs, big spiky burrs. And this is another biennial. It starts as a rosette in the first year, as you can see right here, before it bolts to flower and go to seed. All right, there you go. That's a second year. That's a second year one with some alliums and grasses growing up in between. There's not alliums, galliums. Okay, now we got our daylilies. I hate daylilies. We all pretty much know what those are. And if you see these things popping out of the ground, okay, it's like an unfolding telescope of leaves. Well, it's not always going to be daylily. We have a few native species that do that, but you're probably only going to see those in woodlands. If you see this popping out of your garden, you probably assume it's daylilies, especially if it ends up looking like that. Daylilies serve absolutely no function. You might have noticed that bees and butterflies and flies and insects don't really use them. They don't provide nectar. They don't provide much, if any, pollen at all. And the vegetation itself is inedible to pretty much all our natives. Oh yeah, and it grows just everywhere like crazy if you let it. Lily of the Valley, yep, I'm sorry. No, a lot of people love this one, but it's pretty much invasive in our more shaded, denser woodlands. It's got these urn-like flowers, okay? And of course, it grows up from just one to maybe every once in a while, 3 smooth undulating leaves that come directly out of the ground. English ivy, talked about that today. We all know what English ivy is. There's numerous varieties of it. I mean, there's things that look like it that are, in the same genus as it, and they're pretty much all bad news. Same thing, they don't produce flowers. They don't produce, there's nothing that can eat them. They just sit there and take up space. Same thing with vinca or periwinkle. You've got these smooth green leaves that are sometimes serrate on certain vinca species. And then you've got these 5-petaled, periwinkle flowers where the petals are curved on one side and flat on the other side so that they make that wonderful pinwheel characteristic we love so much. Pachysandra, another very common ground cover I recommend getting rid of. Just like vinca and English ivy, it's totally sterile, but if a little piece of it gets thrown in the wrong place or is forgotten about or whatever, or even just accidentally winds up in a landscaper's truck or on the bottom of your boot, it can cause an infestation somewhere. It is a popular nursery seller, and it really shouldn't be. I've seen this stuff also take over woodlands. Okay. We've got sweet clovers, and we all love our sweet clovers so much. These 3 leaves, kind of like a clover, right? But if the leaves were a lot longer and a little more divided, and then it's got those classic pea-like flowers, that's your sweet clover. Here's another variety. We have two main ones here, the white and the yellow. The yellow, as you can see, is the serrated leaves and slightly smaller but denser inflorescences, which is just a fancy word for the place where all the flowers grow. All right, that Phragmites. Okay, if you see plumes like this, we do have a native Phragmites, by the way, but you're probably not ever seeing it. It is practically extirpated from Cook County by the exotic Phragmites, which completely takes over ecosystems. It is those big, tall plumes of reeds, completely unmistakable, and it is susceptible to triclopyr. You cut the stem down when it's flowering, like you see right here, that's when it's in flower. You cut the stem down about 2 feet, and then you can drip some herbicide down it. Do that 2 years in a row, and you'll kill it. Very tedious, very, very tedious. And we've got narrow leaf cattail. This is a complex one. We do have native cattails, and they are pretty prevalent still. You still see them quite a bit. But the narrow leaf cattail, the main thing to distinguish it from our usually more ideal cattails to have around here, are cattails that tolerate and cooperate with other native species, is look at that. You see, we got the male, we got the male flowers on top here and the female flowers on bottom, and there's a big old gap in between them, okay? Now, cattails hybridize, so this can get really convoluted, and if you have a feeling your cattails are invasive because nothing else is growing in between them, consult an expert, post it online or something, all right? Get a second opinion on that for sure, because this one gets complex. And then also, though, you know, the leaves are narrow, and in the case of narrow-leafed cattail, they're concave a little bit, all right? You see that's what they try to demonstrate with the curve of the leaf right there. All right, Phalaris arundinacea, that is our reed canary grass. All right, I'm gonna show you something really handy here. Most of our New World grasses, actually, I'm pretty sure all of them, all of them that I'm familiar with, do not have this little papery ligule. That's what that's called. Sounds kind of gross. A papery ligule around the leaves of the stem, okay? That's that clear little sheath that attaches the leaf to the stem. Our native grasses don't do that. A lot of our native grasses have leaves that clasp to the stem like that, but they don't have the papery ligule. All right, reed canary grass can also be told pretty easily by those flower heads. Pretty unmistakable. There's nothing else that quite looks like that. And this is when they actually bloom. Okay. That's when they're as open as they're going to be. And then once they go to seed, they look much reduced once again. This stuff responds pretty well to grass-specific herbicides. It can be pulled in small amounts, but it also kind of likes being pulled. It's kinky like that. So you gotta just, let it, you gotta watch and observe for sure. All right, we also got Echinocloa cockspur grasses or barnyard grasses, which have these crazy little spikes on them, these crazy seed heads on them. That's a pretty dead giveaway for you. You'll notice that the leaf also clasps the stem and sometimes has a papery ligule, but really you're looking for these giant seeds that are like little tiny burrs. That is why they're called cockspur grass. Little tiny burrs on the grass, okay? And that's what it looks like on certain species when they're in full bloom. And then there's orchard grass, another really common one. Again, papery ligule, papery ligule, papery ligule. And also these characteristic kind of semi-globular flower heads that look pretty much the same when they go to seed, they just turn brown. All right, easy one there. Moving on. There's, see, there you go. After it's going to seed. Poa pratensis, your lawn. So, well, let's reference real quick here the fact that lawns were not monocultures until very recently. It was basically the idea of a bunch of slave-owning aristocrats who were like, hey, look at how much empty, useless grass I can afford to take care of. Also, I can see all my slaves. That is why they invented lawns. And even back then, a lawn was a matrix of numerous species, which made for a much healthier little ecosystem there. The reason that lawns became popular to the rest of us is because, well, it's just a human thing. We all like to look wealthy, even if we're not. And when chemical companies accidentally made a bunch of herbicides that kill everything but grass, they decided they need to convince us to buy it. So they convinced us that all those other things mixed in with our lawns, which back then was just what a lawn was, were bad. And that all you should have is Poa pratensis, which has absolutely zero value or function to us ecologically. Even compared to native species like common wood sedge or Pennsylvania sedge or pathrush, which look and do the exact same thing and more, while being easier to take care of and more resilient. So always consider that. But there's our Poa pratensis. Japanese stilt grass is just starting to make its way up around here. It's more common down in southern Illinois and the Ohio River Valley and such. So we won't stay too long on that one. But it's got this really, really characteristic habit of growth where the leaves interlock with each other in such a way as to get optimum sunlight onto each and every leaf. It's kind of cool. It's really pretty, actually. But yeah, Japanese stilt grass is one you're going to want to watch out for. Okay, let's not stay too long on that. We're running short on time. House sparrows, they're invasive. They severely, because they're so well adapted to urban environments and stuff, there's not a whole lot of predators that really get at them, but they're also perfectly capable of utilizing resources in our natural environments. So not only are they taking up the resources that native birds could access in our suburban areas, but they're doing it in the natural areas as well. We have many native sparrows. The house sparrows are pretty easy to identify, though, with they got the gray on top of the head, the brown on the back of the head, white cheeks, black mask, black neck. Okay, probably the ones that you see most of the time. I rarely observe native sparrows anywhere but natural areas. Okay, there's the female. We're all familiar with these guys. They're always, if you're on the outdoor seating, these guys are with you as well. Okay, stink bugs. We all know about those. It's another invasive species, emerald ash borer. Pretty sure most of us in Chicagoland in the eastern United States are perfectly familiar with emerald ash borer. Starlings, brought here just because of some really pretentious dude in Central Park who wanted all the birds from Shakespeare's novels to be in America. So he started with starlings, who are already one of the most common and numerically important birds in the old world. And here have no predators or pests. So great. They're also generalists, and they're devastating to our crops, to our economy in general. So there's been reason to get rid of these guys for a while. But the thing is, as far as we can tell right now, there is no getting rid of them unless we figure out a pest or a disease that we can guarantee only will affect them. And that's years of experimentation. Okay, carp, these derpy looking guys with the droopy eyes. Okay. Luckily, we're starting to combat this problem. Salt Creek is relatively carp free. When I was a kid, I used to see them all the time, and I haven't seen one in about 4 years in Salt Creek. That's great news to me. They're accompanied in the creek by our rusty crayfish, one of several species of crayfish around here, and the only one that's invasive. But yeah, you can pretty much tell a carp by the gross palette of its skin and the droopy eyes and the big mouths. There's not a lot to go off of here. They're pretty easy to draw. Let's see. Japanese beetles. Everyone knows these guys. Okay. They are generalists as well. They will munch on pretty much any foliage. One of the few insects that can do so, actually, including our ornamental and exotic species, which is just kind of wild. These guys are crazy, and our best bet at getting rid of them, well, if you see them on your property, I go ahead and smash away. But we're going to need, again, something more scientific, something more experimental to actually eradicate these guys. But I really advocate for, if you see them in your garden, go ahead, smash them, but don't use pesticides on them, because you're just going to be killing anything that possibly might eat them. Okay, earthworms. I told you we were going to get back to that. So earthworms were extirpated from this region by the glaciers, the Wisconsin glaciation that was here in this part of Illinois last about 10 to 11,000 years ago. And the way the glaciers scoured the earth and then deposited all this new fresh soil on top of it, there's no way the earthworms were going to survive. And 10,000 years is not enough time for them to migrate this far north from the southern parts of Illinois where they are still native. So they got brought here partially or mostly by accident, just in ballast, in samples of plants or the crops or whatever that were shipped overseas. They were just, their eggs and casings were just in the soil there. There was really not a lot they could have done about it back then. This is one of those things that's just a sheer effect of global trade, and we really have no methods of getting rid of them, but we need to be aware of their ecological impact and probably should stop introducing them to the environment and exalting them so much, because our native ecosystems have thick layers of soil, very, very distinct layers of soil, topped by humus, which is topped by duff, which are varying stages of decomposition and plant matter and feces and all that other stuff that ends up down there, you know, space dust, whatever. And our plants have survived and adapted to those distinctly layered, segregated conditions for the last 10,000 years. So when earthworms come along, there's really nothing that is keeping them from mixing up that whole structure, bringing nutrients from the top of the soil down to the bottom, where none of our natives have evolved to really access nutrients at that level. We have our plants have different cells for different things in their roots. Some pick up water, some pick up nutrients, yada, yada, yada. All right, only water roots get down to the depths that earthworms go, so not really helping them. You can, along with buckthorn, which these guys love. They love buckthorn because they love highly nitrogen-rich leaf matter. Along with buckthorn, earthworms can absolutely destroy a millennia-old woodland in a matter of years. And finally, oh yeah, your cats. Your cats are fine. I like cats, but just keep them indoors for the love of God, because they are definably an invasive species. They really devastate local rodent and amphibian. And if we had a lot of reptiles, they would also devastate the local reptile population. And we may not think about it very much, but deer mice and voles are a keystone species in our ecosystems around here. We wouldn't be getting far without deer mice and voles and everything that they do for nutrient cycling and moving food and resources around. Same thing with amphibians in our aquatic environments. They're extremely essential, and they're a necessary bioindicator as well, which means that they can tell us about how the ecosystem's doing health-wise. Cats just kind of ruin all that stuff. They compete with our native predators, take a lot of food out of the system for them. Basically, they're just way too efficient of killers. They're great. They're just absolute madmen, homicidal maniacs, and evolution kind of perfected them. So we got to just contend with that and not let your cats outside. But yeah, let's see. I think we're pretty much at the end here. I think, oh yes, I see Donna. Yes, those were jumping worms in the picture. Absolutely. And basically, just without further ado, let's get with the rest of our presentation here. But yeah, so those are all of our. Oh, hey, are we done?
Are you all finished?
Yeah, we're pretty. I think we're all finished here. That was the lineup. I think the last thing to say is this was an ad the entire time, and if you, no, just kidding. If you guys need somebody to tell you what's going on in your ecosystem, or need somebody who knows how to get rid of your invasive species, it just so happens that that's what I do for a living. So go ahead to wyattcoyote.com. You can learn more from my YouTube, Instagram, TikTok, etc., and from my website. Lots of resources for you on there. And you can reach out to get somebody to help take care of your ecosystem for you. So